Yeah, welcome back everyone. So now we are going to start the first session by Professor Ashish Bhaskar. So this 5 day journey starts now formally. So we'll start with like very basics and maybe like I'll invite Professor Bhaskar to take over this session. Please.
Thank you, Akhilesh. Thank you, Mr. Akhilesh. So welcome back, guys. In the last session, I was asked to talk about myself. I thought, no, I will talk about the next one. But before I start, how many of you are undergrad students? None of you here? Master students? Master in civil engineering, transport engineering? Yes. Yeah. How many of you are PhD students? Yeah. And how many of you are professionals? Perfect. So about me, I will start with that one first. I did my, before about that, I am currently a professor at QUT, the Queensland University of Technology. I will talk about that university pretty soon. I joined QUT in 2011 as a lecturer after finishing my PhD from École Polytechnique Fédérale de Lausanne, which is Swiss Federal Institute of Technology in Lausanne. I was there for 6 years. I did my PhD and also 1 year postdoc. Then I got an opportunity to work at QUT, and since then I'm at QUT. Before that, I did my master's in civil engineering from the University of Tokyo. So for a master's, it was a totally research-oriented master's. So I would say I learned how to perform research from under the supervision of Professor Masaru Kohara and Professor Edward Chung. So that's where I actually started my research journey. I did my research in road traffic noise modeling. Afterwards, when I went for a PhD, I didn't want to work on noise modeling, so I worked on something else, which at that time we focused on arterial travel time estimation. My undergrad is from IIT Kanpur. That's why it's so nostalgic to come back to the I would say IIT campus. Yesterday I was walking around. It feels so good. It feels good only when you have friends with you, not alone. And in fact, I was having a chat with Professor Akhilesh. He joined the year I left, so we had almost like 1 month common, hopefully, between us. And he was asking me what was my BTP. So I worked on geotechnical engineering. So after long, I remember, okay, something I worked on. Now I'm coming all the way from Brisbane, which is the east of Australia. Indians, we love cricket a lot. And I came to know about Brisbane by watching the match at Gabba. So you might have heard about the stadium Gabba. So that's actually in actually this Brisbane. Population of Australia is very small. Like India is actually producing one Australia almost every year. The Queensland is the state where we have Brisbane. So Brisbane is the capital of Queensland. I want to highlight one thing, that Brisbane is actually hosting Olympics and Paralympics in 2032. Now, when you are going to host such mega event, what do you think is the impact on the transport network or transport system for any city or any state who is going to host it? So what's the impact? What's the benefit for the transport system? So I'm asking you a question. Like, can you think of the benefit of hosting a mega event from the transport network perspective? And I heard that India is, in fact, is now news, if I'm not wrong. India is targeting the next Olympic after that. So they have submitted the bid for it, and hopefully, I think Ahmedabad or the state of Gujarat might be the one which will be putting forward a step. So what do you think? How hosting a mega event or planning for that mega event can help our transport system or transport network? Upgraded, yeah, but they will not get upgraded just for that event. So this mega events, basically they act as a catalyst. They give a strong boost to the projects which have been there. I mean, our road agencies, our government, they are always planning for the future. So there are number of projects in pipeline. It's not that they're not in the pipeline, but we don't have funds. So when you aim for something big, it naturally gets more weightage. So it gets more importance, and all of a sudden, you try to look at the ways by which you can really, because you are now inviting other people to your place. It has to be of the highest standard. To hold a mega event, there are a lot of challenges. I mean, all the way from planning to the operations. And when you are at the operation level, you have to make sure that the athletes are able to move from point A to point B on time. They are able to be at the stadium on time. They are also back in the hotel on time because they had to rest. And then you have a significant amount of spectators, you have to make sure that they are safe, they are given the reliable journey. So your transport system in itself has to be working in a very optimal manner. Otherwise, that actually event will not be a success. Indeed, our transport system, our transport network is the backbone of the economy. It is the veins of our entire, I would say, economy. So when we are hosting that big event, it really helps us to boost our investment in the transport system and more. And the one which really gets a lot of, I would say, support is sustainable mode of transport. Your public transport really gets a big boost. And generally, when you are planning for this, you don't plan, as I mentioned earlier, you don't plan for that event, you plan for the legacy it is going to leave behind. So it's not just one event, it's what's actually going to be behind, beyond that. That's an old picture, but it shows the city from where I come from. But more important, I'm trying to show the Queensland University of Technology, QUT as we call it. We have two major campuses. One is the Gardens Point campus, located along the banks of the Brisbane River. We have another campus at Kelvin Grove. From transport perspective, this campus or this area was developed with a transit oriented development. So they focus on the transit part of it. Gardens Point campus is at the heart of the city. That's the city CBD area. It's at the heart of the city. And I like this picture, and I use it not just to introduce QUT, but also to introduce the transport system in general. You can see here, there is, so in fact, organically cities are developed by basically having the population density along the river, because that's the main source of water from the old civilization days, or the main source of energy for us. So the whole city generally is divided between north and south, or east or west, depending on where you are on the side of the river. So Brisbane has Brisbane South, which is further down, and Brisbane North general. In Brisbane, we use this river quite efficiently. You can see that there are a number of ferries running. So you have ferries as one of the mode of transport, and these are the ferry terminals that you see here. So you can utilize that river as one of a sustainable mode of transport. In fact, the future ferries or even some of the ferries now, they are going in the electric mode, because we want to have a sustainable mode of transport. Then there is a bridge connecting between north and south for the traffic. In fact, that's the motorway section. And you can see some of the buses. I mean, you can't see that, but I know that these are some of the buses on the motorway section. So it's a motorway section that is connecting both north and south of the city and carrying a high amount of traffic. More important is another bridge here. We call this as a green bridge. Its name is Goodwill Bridge, but here only cyclists and pedestrians are allowed. The cars are not allowed on this one. And this connects a university or the entire CBD with the Brisbane South. So I live in actually Brisbane South. So I travel, I take a public transport, move out at one of the south terminals, and just walk around the city to come to the university. Now we have one more bridge here, which is connecting another, I would say, South Bank area, which is very much, I would say, recreational area. A lot of restaurants are here, connecting both the sides. So city is expanding, and it's naturally expanding because the population is increasing in the city. But it shows quite well about the different modes of transport. So transport is not just cars, it's not just cycles, it's not just buses. It's a integrated mix of all of them. An efficient transport system is when everything is integrated, and the optimization can only happen when you try to integrate them. Bit about QUT. I would say QUT is one of the best universities in Australia. I'm not saying this because my salary is coming from QUT and that's paying my mortgage, but I'm saying this because I have been there for the last 11 years and I've seen that how ambitious the university is. I don't believe in the ranking system, so don't worry about it. But what I'm trying to say here is QUT has gone a long way. It was like 20 or 30 years back, it started as a teaching university, because teaching is our main core of business. So when I say institutes or universities, teaching comes first, then starts the research part of it. But both of them are equally important, because you bring your research into your classroom, then only you can understand the importance of what you are learning. So it's a complete system. We have around 50,000 students. It's a big university. All the faculties are here, all the way from business, engineering, Right now we have 5. Every couple of years they reshuffle, so things change. But we have a huge number of students, 8,000 international. Number of them are from India also. We are offering both masters and postgrad and the undergrad course. I would just like to advertise our undergrad course, which have just started recently, which is a specialization which is providing specialization in 2 areas: smart transport and water engineering. We started with these 2 because QUT has at least the School of Civil and Environmental Engineering has a critical mass in these 2 areas. So we started with this one. I am actually teaching advanced transport modeling and also some artificial intelligence in transport with one of my colleagues. So those, I mean, in fact, you are a master's and PhD, but those who are online or who might be watching this lecture down the line, if you're interested to actually pursue masters abroad, this might be a good course for you. Now, transport research group at QUT, I want to show our research strength. We have number of actually academics. Professor Shimul Haq is our head of the school right now. He recently started as head of the school. He is internationally known for his expertise in road safety, especially using video analytics to actually study the road safety aspect. Professor Alex Paz, he is a transport chair professor working on number of things, including, I would say, agent based simulation and also mobility as a service. Professor Jonathan Bunker, he is expert in public transport, working in the area of transit capacity and quality of service. Professor Shams Yasmin, who has recently joined us as a full-time faculty. She is working in the area of transport equity and also on transport modeling. Professor Sebastian Glacier, he is working in the area of more in the ITS domain of connected and autonomous vehicles. Professor Mark Miska, he is working in the area of asset management. We have different centers: Center for Accident Road Research and Safety, which is in the Faculty of Health, focusing on the road accident part of it. We have Center for Data Science. I work very closely with them. I am one of the chief investigators for Center for Data Science, and transport plays a very important role there. So a lot of interest is there regarding how we can use transport data set, apply the learnings from the data science to address the transport problems. Center for Robotics, in fact, QUT is ranked number 1 in Center for Robotics in Australia, and I used it because they are working on autonomous vehicle technology. Then Center for Behavior Economics and Society and Technology, where people work on behavioral economics part of it, and transport also plays important role in that one. And last but not the least, we have a Center for Automated Vehicles in Rural and Remote Regions. So there are a number of, why I want to show this, show that okay, transport is not just one aspect, it's actually quite broad. And especially those who are master students, if you are interested to do a PhD, QUT is actually one of the good universities to come for. If you want to do a PhD, or even if you want to do a postdoc, please feel free to approach the academics there. PhD deadline is the 1st of August generally, and the application deadline, but you have to start a bit early. You have to have a complete application by actually 1st of August through an agent in India. So you have to start, let's say in the month of January, February, start approaching an academic, talk to him or her about the area of research, prepare a research proposal and submit it on time, I would say before 15th of July. Now, that's my area of research, and I will take this slide to tell you what I'm going to teach also in the next 4 or 5 days. So this is, the way I differentiate myself with my other colleagues is that I'm primarily working in the area of transport data analytics, modeling, simulation and control. Now this thing I did not plan from day one. When I was doing a PhD, I never thought I'm going to work on this area. It just organically evolved the way I was working with the agencies. So starting with the Bluetooth data set, the traffic data for Bluetooth, Brisbane was one of the initial cities which has adopted the use of Bluetooth to actually manage the traffic network, or at least to do the transport observations. We got access to the Bluetooth data set, and I will show you in my slides that how we are working closely with the Department of Transport and Mains Road and the Brisbane City Council, or the key stakeholders, how we are getting the data set from them, and that data set provides valuable information about how the people are moving over the network. And from the Indian context, I think Bluetooth, Wi-Fi might be one of a very good source of data that can really help you to understand the mobility of the people. It's a very, I would say, cost-effective means of collecting the information about the mobility. I will introduce something. I will introduce the loop data set and talk a bit about Streams, which is an ITS platform used by the Department of Transport and Mains Road to manage both motorways and arterial. We are thankful to the department that we have direct access to the Streams terminal, so we can download the data for the last, let's say, 6 months straight away for the entire state of Queensland from that terminal. Department is also getting data from third party, let's say from here or from telematics or Waze, and based on the projects we have done, we got the data set from these sources also. So number of things which I am going to discuss in this lectures will be also the knowledge I have gained by analyzing that data set. I use the word CAVI here, which is connected and autonomous vehicle technology. These are, I would say, like more advanced data sets where you can get the position of the vehicle every 1/10 of a second. So in Queensland, we have an initiative by the department where they had equipped around 500 cars with that CAVI technology, and we have used that data set for understanding different aspects, including road safety and also how it can be used for traffic signal operations. And obviously you have transit data, you have travel behavior data, but I use the word data visualization. This is important thing which I am going to stress in my talk, that if you just get a data set and they are quite huge, data visualization techniques or tools or strength is very important for analysis. So that's why I put data visualization also there, and nowadays my team is using that a lot. Without visualization, you cannot understand what's behind it. Then obviously this data set is just a data set. What do you do with it? And a lot of PhDs have emerged from the data set, focusing on modeling and simulation. We have worked on both demand and supply modeling. I think in day 3 or day 4, I will talk about simulating the large urban network, which is going to come from this. How do we calibrate the demand models for the entire city using the data set that you get from there? So that's where the demand and supply modeling comes in. I'm going to talk about traffic state estimation, how you can fuse the data from multiple sources to estimate the traffic, whether it's a travel time or traffic density. In fact, with Akinip Jyoti, the initial discussion I had a number of years back was on traffic density. So how you can use that. Obviously, you also utilize the data set to understand the traffic behavior. I'm going to show you a number of fundamental diagrams from the real data, so that you have understanding of how the fundamental diagram really works. And in theory, you might have studied about hysteresis. I would like to show you how hysteresis is really forming from the data we have got from the real network. I'm going to talk about the macroscopic fundamental diagram, which is, or it's a network fundamental diagram. You have studied about the fundamental diagram for one section, but if you combine multiple sections, how does the entire, that you have a similar shape for the entire section, and show it by the example we have done in actually Queensland. Later on, I think in last day we will talk about some of the research needs, and 3 of us will discuss about it. I might focus mostly on a bit also on the need for research in electrification of transport, where when we have electric vehicles on the road or even the electric buses, we need to have sufficient infrastructure to actually charge those ones. In fact, these electric vehicles, like Brisbane is heading towards all the buses getting electric in different phases. In fact, almost at all the places we are now heading towards, the public transport is the first one to be electrified compared to the ones. But these buses are going to be electric in phases. And as you know, your phone battery, it dies quite quickly. After a couple of years, the battery strength goes down. Same thing will happen with the buses. So you will not have the bus with almost 100% capacity every time. So what's going to happen? When you are performing your public transport rostering, you say, okay, for today, I need, let's say, 100 buses running over these routes. And you give it to the operator and your contractor, and they have to allocate the buses to that roster. Imagine all the buses are electric. Your need for energy is different for different routes depending on the weather condition. If it is a hot day and you're using air con, you need more energy. Depending on the traffic conditions, if the traffic is congested, you need more energy. and depending on the load, how much load is in the bus. So there are a number of factors which is going to contribute to the energy usage. Now electric buses, you have to understand how much energy they are going to use, and you have to optimize your allocation. That leads to a totally optimization problem from mathematics. But what I'm trying to tell you here is a real world transport problem. You have to understand the problem first, you have to understand what are the constraints, and then you do the optimization. Other thing which I forgot to mention, I mean, although I use the word optimization because when we are talking about it, we just use the word optimization. I'm not going to talk anything about mathematical optimization. So do not expect me, I'm going to talk about gradient descent, stochastic. No, this is not at all a maths lecture. In my whole talk for the next 4 days, I might not use any equation. I will just tell you what I know from the practice, from my engagement with the industry, and how my researchers have been working on it. You want to know about those things? Go and read the paper of my PhD students that they have worked on. So I will try as much as possible not to talk about those things. Try to make it more generic so that we interact and basically see the conceptual framework behind it. So I like what actually Professor Bhattacharya was saying for optimization. In fact, a lot of optimization that I'm going to talk about here is actually from the field experience of the road agencies. Yeah. Then obviously control comes, where I will be talking about the traffic signal control on the RTL network. And other thing I want to talk about is how the motorways are actually controlled in terms of the ramp metering and the variable speed limit. The challenge I'm going to face there is how to link it to the Indian condition, which I'll be thinking over the days, and we'll be discussing about it. So that's in one sense a snapshot of what I will be talking about over the next days. But this also maps for me to see how my research has progressed organically. So this is something I didn't plan 10 years back, it just happened that way. Oh, I'm muted? Okay. Is it my microphone or is there? Okay, yeah, good then. But are you able to hear the the microphone voice or my voice? Mine? Mic, okay, that's good then. Because generally if the microphone is not working, then you can't hear that. Yeah. Working? Okay. Okay. Sorry to the online audience. Okay. So that's what I was trying to say, that I'm basically academic more on this side. So if you look at the academia, you have one who is working more on the theoretical side, one is working more with the practitioners. So I'm trying to be a balance between the two. My PhD students are the one who do all the fundamental research, and we try to put into that scientific journals. And with academia, we try to understand the problem and try to solve those problems. And in this next 4 to 5 days, I will be focusing more on this part of the world. I'm quite sure in actually IITs you have learned a lot about the fundamentals. But I will be talking about those fundamentals also, but focusing and try to bring that experience from the interaction with industry. This is the most important slide. I want to acknowledge various stakeholders. I've already mentioned about the Queensland Department of Transport and Mains Road. We are very thankful for them, to them, that they have shared the data set with us. They have funded a lot of my research, and a lot of things which I'm going to discuss are from the Queensland network only. And this is only for teaching and research purpose. I understand the complexity involved in managing the big transport system. So in fact, there is never an optimal solution. An optimal solution for academic is different from an optimal solution for the practitioners. You might come up with a very good optimization, say this is the best solution, but based on your constraints with respect to the budget, nowhere you can reach to that solution. TransLink is the public transport, I would say, regulators. So they are under PMR. We have used a lot of their data sets. So I'm going to show some of the examples from their data. Transmax is the one who is also under PMR. That's a company which is managing streams, the ITS platform. I'm going to show you some of the, or I'm going to share some of the learning I have using streams. We have collaboration with the also with the private companies like Compass IoT. Compass IoT is one of the companies in Australia which is sharing the connected vehicle data set. Very valuable data set. So if you get data from, let's say, road network from loops, you know there's a fixed infrastructure, you know what's happening on the loops. But connected vehicles, you get the information about the entire trajectory of the vehicle. Now both of them alone will not add that much value. When you combine them together, that's where the actual synergy is. So the Compass IoT has shared some data set with us. The knowledge has helped me to understand how that vehicle trajectory really looks like. iMove has funded some of the projects. Brisbane City Council has given us the entire data set for the entire city of Brisbane for the Bluetooth, which I will show. Aimson, which is a traffic simulation software company, we did a project for them to actually optimize, to actually model the entire city of Logan and try to learn try to do R&D for Aimson live in that city. So in day 3, I'm going to talk about that project. Mainsfield Western Australia helped me to understand how the Bluetooth dataset can be used for other applications. So Bluetooth generally is used for travel time estimation, but there are other applications also that Bluetooth is used for. So when I was working on a project with them on their dataset, some of the ideas came up. Plus we have NetBI and black and white taxi cabs. I would like to acknowledge number of academics, both within QUT, but outside QUT also. We have a long collaboration with SVNIT, with Professor Srinivas Arkatkar, and in fact a number of my PhD students have come from SVNIT. So definitely, like that's the recruitment ground for us. We have a joint PhD program with IITD, and in fact one of the researchers was there with whom we have worked. I will show some of the slides from the work he has done in terms of defining the road network from the connected vehicle data. With with IIT Madras, IIT Chennai, we have a joint PhD program with Professor Lalita Banerjee. I have been working on traffic signals, and some of the knowledge I am going to share today is based on the discussions I had with her. With IIT Delhi, I am working with Professor Kalgar Rao, and focusing on more on the Indian safety side of it. So I will share some of the things from there, plus a number of other institutes. Now, why I am saying this is, what I am going to talk about is not just my own work; it's a work which has been with them, and some of the slides which I am going to share might be from the discussions which I had with them, or I might have borrowed from there. So it will be hard for me to acknowledge on each and every slide. I'm acknowledging them there, but most important, I would like to acknowledge my team, both past and current one. This is the current one. I don't have a photo for all the past members, but they are the one who have done all the hard work. They do all the hard work, and we academics always proudly claim their work as our work. So they actually, they do a lot of research, and we discuss with them. They say something new concept. We ask them to go and explore that concept or explore that technique, present to us, and we jointly learn. So a lot of knowledge which I am going to share with you is based on the discussions with them also. So that's the acknowledgement I want to do before I start my lecture. But again, this is, I try to use this opportunity to explain what I'm going to teach over the entire 4 days or 5 days, and plus acknowledge the key stakeholders. Any questions so far before I move to the first lecture?
Have you studied with respect to the social and economic impact?
Not personally, me, no. I have not studied that myself. But we have, like when you say study means to do some of the modeling work, no. But we have borrowed the literature. Like for example, in the next presentation, I'm going to talk about what is the impact of congestion on the economy. So we get some value. In fact, this Department of Infrastructure, Transport, Regional Development and Communication and Arts, they have a big division who is doing all this modeling to understand the impact of transport system. What's the impact of congestion? What's the impact of the road incidents and all those things? So they come up with the dollar value, and we just borrow it to make a case why we want to do the work that we want to do the work. Yeah. Any other questions? Yes.
Since I'm not from the academy, it's for me. But should we take notes or anything would you like to prescribe? We are not going to take.
Yes, at the end, like maybe we can
Yeah, we can share them at the end. So I think yeah.
PDF will be shared
Mhm.
subsequently.
Yeah.
Um,
Yes. Yeah. And in fact, in the last day, we have put the last day to actually talk about things. I'm going to get the key messages also, and put them as in the slides. Yeah. So that I think maybe in the last day we can actually give you the one actual presentation which talks about the key messages we have learned. Yeah. Yeah.
Most of the lectures, like we will compile and we'll give you the PDF
Mhm.
access, not in hard copy.
Yeah. Sure.
So you can note down like whatever you feel that which is not available in the slide.
Yeah. Yeah. So I will definitely get the slides for you. I didn't give it early because I was preparing few of them this morning, so it will change as I'm going to go through. Yeah. Good.
One more request that you become more vocal because it's not like lecture class.
Yeah.
Like you are here to learn. So like whatever is your query, just keep asking. Just raise your hand and let's ask then and there. And like maybe more you interact, like even instructor will be, it will like feel instructor that you are able to understand. He can go more and more deeper. If you're not responding, then it become very difficult. Like whether everything you are able to understand or everything is going above head. So better like keep responding. Don't behave like you are in lecture class, like you are in UG class or PG class. Okay. Thank you.
Yeah. Thanks a lot, Akhilesh. That's important thing. So please ask me questions as I'm speaking. Yeah. And also, if you feel what do you call it, a bit sleepy, please feel free to stand and stretch yourself and go out. Right. So don't feel shy. Better to be fully attentive than to just hold yourself until I'm talking. Because I'm talking, I can talk about things, but I know when I'm on the other side, I can be sleepy after 15 minutes quite easily. Okay, so that's the first one. I close this. Now let me talk about the fundamentals of traffic flow. I'm quite sure this will be quite easy for the PhDs and the masters who are in the advanced stage. So I will ask a question first. Why do we need to optimize transport network? What do you think? Like, why do we have to optimize the transport network? Yes. Okay. To reduce congestion on the network. Yes. Good. Minimize the fuel consumption. Yeah.
Also minimize the traffic congestion.
Yeah. Good.
Increase the user experience.
To make a better user experience. Yeah. Increase the reliability of the system. Yes. Cost effectiveness. That's very important.
To increase safety, serviceability, comfort.
Yeah. Perfect. Yeah. So there are so many reasons that actually we have to optimize at the transport network. The time wasted in traffic is the lost productivity. I mean, everybody is stressed when they are stuck in traffic. Instead of spending a quality time with your family and friends, if you're stuck in traffic, it's a total waste of time. So, and that actually increases I would say frustration. And you have seen that on the road network, people are honking a lot. They honk a lot because they are frustrated. And that frustration goes to their family and actually have a big impact also. It impacts the health. For example, in terms of the time wasted, this is the slide I just put in the morning. I was having a look on the TomTom data. So don't worry about the ranking here. But what is important here is among those top 10 slowest cities in the world, unfortunately, 3 of them are from India. And what you see here is around 110 hours on average a year is lost just being stuck in traffic for each on average a person, right? And I'm quite sure the standard deviation is very high. It might be skewed more towards the right end, but 110 hours just lost in traffic. So you are not able to do much work in that time period. You are not able to spend time with the family and friends. You are stressed, and that actually further adds to your loss in productivity. So that has an impact on the economy. Now these hours are converted into a dollar value by economists, and we just borrow the values from them. But you can see the amount lost. That's why you really have to, we take the transport system quite seriously. That we have to look at the ways by which we can make our system more efficient. By doing so, you can have a seamless transport. Even for example in the airline industry, when I was trying to come here, I was having a chat with the Professor Akhilesh that okay, I'm landing at 2:30. I want to come here as 2:30 in the afternoon. I want to come here as early as possible. So we discussed okay, maybe 3.5 hours is the buffer I should consider, and my plane was around 6 o'clock. But Delhi airport is so busy, even if you are going to a domestic one, and that airport security is always tight. So it takes that much time. But if I would have missed that, then my next connection I would have missed further. So you want to have a very reliable system. In fact, Japan is one of the cities which is a perfect reliability there. You go to a meeting, you know, okay, I can take this public transport, I can be there just 2 minutes before the meeting, and people work that way. And they are able to, the average delay on, if I'm not wrong, is less than I would say 8 or 9 seconds on the Japanese metro system, and they work perfectly on time. If they give you 15 minutes for presentation, you only have 15 minutes for presentation. You don't spend 20 minutes there, but they value the time a lot. So think about the amount of time lost. It's a huge amount of time which is lost. And recently there was another news from INRIX which has shown that the Brisbane is unfortunately the most congested city in Australia. Maybe the others have increased, but I think Brisbane congestion has significantly increased, 84 hours. So on average, I might be losing 84 hours in a year. Here you're losing 110 to or actually even more. So that we hate. We want to make our system efficient so that people do not lose the time unnecessarily time is wasted in traffic. So loss of productivity is there, which has an economic impact. It also increases your emission, which has the health impact, right? The wasted fuel, and obviously the mental stress and the quality of life. I can tell you, like last couple of years, I was driving a lot in Brisbane just because I want to drop my daughter to her school. And the traffic used to make me so crazy because the school time I have to drop her. I also have a meeting. If the traffic is there and you are stuck in traffic, you're thinking something at the back of the hand. It really impacts the quality of life. So, and in fact, it's something we all feel. So somebody asked what's the value. I think this is the dollar values which come from the Australian government. It's around 16.5 billion was estimate in 2025. In general, I would say it's close to maybe 1 to 2% of the GDP of the entire country in general. So think from that angle. And generally, what you see is that if you do not do anything, the congestion is going to increase dramatically. And these values or these figures are used as a business case to invest into the major infrastructure projects. So this is very important part of transport economy. I don't think we have universities with various experts in the transport economy. The only few universities are there where the experts are focusing on transport economy. But these values are used for all the business cases. If you want to invest, let's say $100 million on a project, that project should definitely give you a benefit of $300 million, and you want to show that with respect to all the econometrics modeling you do or the economics modeling you do. So how can we reduce congestion? So we have identified, yes, to optimize traffic, we want to do that optimization because of the traffic congestion. So what are the ways by which you can reduce congestion on any network? So mass transport, take the people out of their personal vehicles, bring them on the public transport. Yes. Yeah. Have more. Yeah. First and last mile connectivity is very important. So make system more sustainable. In fact, IITs are the good example where people use like cycles and walking a lot. But if you go to the city, you don't do that. Why? Sorry. We can't because of safety, pollution, yeah, lack of infrastructure, yeah. So let's have a look. Yes, so this is the current triangle or prism you have. A lot of personal transport is there. People are driving. In fact, unfortunately, in the developed world, you only have, let's say, 1 or 1.2 people on average on each car. So you want to shift the people. You want to reduce that personal car usage. The walking or this micro mobility is quite less used. So you want to build your cities in such a way so that the shift is from here to actually here. Yes, you want to increase the use of actually public transport, you want to have an integrated public transport, you want to increase the car occupancy, and different strategies you actually implement so that actually this shift is done. For example, congestion pricing, that is defined to reduce the use of your personal vehicle. Reducing the fare of public transport, but more important is making it more efficient and reliable will attract people to use public transport. London is a perfect example where they have the congestion pricing, but they use that money to actually upgrade the public transport system. We cannot think of congestion pricing unless we give an alternative to the road users. That's important. So we need to have a very good policy in place to see, how we can move things around. You just cannot increase the number of lanes on the road because of number of constraints. Dollar value is actually one of them, or the cost is one of them, but again the space is also. But again, if the system is fully congested or the demand exceeds the capacity, you have to look at the ways by which you can increase the capacity. So network optimization is one of the things that we use, and when I use the word network optimization, it means that squeeze as much juice as possible from your existing resources. That is what is meant by network optimization. Before jumping into a big one, how I can better use my existing infrastructure, and that's the place where number of things play a role. Like we talk about how I'm going to talk about how we control the motorways and traffic signals. If you optimize your control parameters, you can get more traffic flowing within the network without investing too much on the new infrastructure. So that's the summary of what I was just talking about. Any question so far on this one? Now, whenever you are actually writing any research proposal, you have to make a business case for it. So if you are proposing anything, so these things is basically you have to tell a story. It's always a story that you have to tell. You say, okay, existing cost for your, let's say if I'm writing a proposal on traffic congestion, I will tell them, look, the current, that's the issue, that is the what is costing you. That's the solution I'm coming with, and that solution is going to have X amount of benefit to cost ratio. So whatever I've said so far is an important part for you to understand or tell the story for any case that you are making. So now I'm going to discuss about transport system cycle. I'm using the word transport here, but it is equally applicable to any system. What you have is, you have your transport network. So when you want to do the optimization in actually using the real network, you have a transport network where you might have a multimodal transport network. You put sensors, or you need to have data from that entire network. You need to understand how your network is performing. I've used some sensors here, but if you think about, you want to upgrade an intersection in India someplace, you will go and have a study first. You will observe how much is, you will do some survey to understand how much is the traffic coming from different approaches, how much is the demand of that one. Unless you have that, you cannot make any decision. And then you try to see, okay, with my current system, let's say I have X amount of demand or people who wants to use the system, and then you say, look, and the delay is that much. So you do that observations. Then there's a control center, where in fact this photo is from the Tokyo Metropolitan Expressway. So Tokyo Metropolitan Traffic Management Center. When I was doing my master, I took a photo at that time, and I'm using it since then for my lectures. It's a big network you can see here, managed by the metropolitan experts and the police. But what's happening there at the back end is, you're getting the data set, historical data set, which you actually maintain. But before jumping there, let's say you know how to control it, then you have actuators who is going to control the traffic. It can be more automated actuators like traffic signals, or it can be, let's say, your policeman standing at the intersection controlling, or whatever other means are there. So the way you are going to control your network will define your network properties, and that's going to be observed further, and that's the whole cycle. Now I've used this word transport system cycle. It is, any system behaves like this. You have a system, you have your observations, You have a model that helps you to make the decision. Now, as I was saying that the data goes here, there is a historical database. You always have certain parameters for that control that has to be fine tuned. So those parameters are there. It can be mathematical models, it can be heuristics. They have to be fine tuned for the site, and that's where the expert knowledge plays a very important role. If you do not do anything using advanced data science things, but you have a historical database, you can do some estimation modeling to have a better understanding of how the system is behaving, because you will never have the perfect knowledge of what your system is all about. Like even if you talk about the human body, we go and do, let's say when you cross the age of 40, you have your blood test every, let's say 6 months to 1 year to tell you how much you are at the risk of a heart attack. But you do not know when you're going to have a heart attack. Hopefully we should never have that, but I'm saying that you have some observations from your human body that tells you some chances of some disease in you, but you do not know exactly what's happening in your network, in your own body. Same is with the transport network. You have some observations from some sources, from some locations, but you do not know exactly what's happening over the entire network. So that's where the estimation comes in, plays an important role. You want to, based on your limited observation, you try to estimate what's happening over the network. Obviously, you will have to then make some forecasting, some prediction modeling plays role, and then you have some goals in mind, and you use those, with those goals you try to optimize your network. Now these goals can be contradictory to each other, they might not always be the same. Can you give an example of the road where you have two separate goals, one of them, and they might not be exactly going the same direction to do the optimization of the network? Is an example. Can think of the true goals in transport. As a transport engineer, let's say you might have two goals with you, and they are not in line with each other. Perfect. Safety and efficiency. You want to have a safe system. Safety is the topmost priority. We do not want any incidents on the road. We do not want any accidents and fatalities on the road. On the other hand, if your system you're trying to make it too safe or totally very safe, you will have some efficiency impact. For instance, you try to reduce the speed limit close to the school zones. Why? Because of the safety reasons. But reducing the speed limit creates some congestion. That's fine. You are happy to have half an hour extra on the road network if you're able to save a life. So safety and efficiency don't go, basically they don't have the same optimal values, and then you have to weigh which is more important at that specific location. But that's the whole transport system. And in fact, in my lecture, I'm going to talk about, I think today or tomorrow, I'm going to talk a lot about the traffic sensors, so that's very important for you to understand. I'm going to talk about estimation and then also the actuators part of it. Questions on this transport system cycle? Yeah. So I use this as a control center example. So if the middle part is like this, I said in general, for example, let's say you have an intersection. You have a group of intersections, for instance, right? And you want to control those intersections. You might be getting data from the multiple intersections, and then there is a control center which in this case might be a roadside unit which is controlling multiple intersections together. So it knows, okay, how much is the flow occupancy for various locations, and it tries to change the signal timings. So then your signal timings are changed accordingly. So there is an algorithm behind it. So control center is a kind of a brain, an algorithm behind it that directly does that. Another example is this control center which you see here is a big center where you have different observations. You have different CCTV cameras. Suppose there is an accident happened at actually one location. Then so there is an accident on this location. I might have to divert my traffic, or I might have to inform the police and ambulance and all those things. So you make a decision accordingly, and that is the one which is going to change your transport behavior. So it is actually quite generic. You can think of this as a simple intersection with a single observer. Think of this also as a policeman, for example. A policeman is standing at the road. He is just observing the traffic from all the 4 locations, and then he's making a decision, okay, I'm going to give this guy more because I see a longer queue here. So then this control center is the brain of that, is that policeman, and he is changing which one to give, how long green he is going to give. So it's quite generic system, like even as a policeman is doing some, making some decisions accordingly. Yes.
Are these systems integrated during the conceptualization or after you have already built the infrastructure? How does this go? Because if you take any new city, like in India, you have smart cities, even new cities coming to that story. But the transport system cycle probably will come later on. So then we think like these will be mostly surveillance, and but maybe that is not the full thing, right? There is both surveillance and
Yeah. I mean, as a given example of a simple policeman, think of this as a single guy. You standing at an intersection, or a policeman standing at an intersection, observing traffic, making a decision. This, when I say transport system cycle, is this is how the decisions are made. So it can be at a single person level to the big network level also. So your question is how they are done at the city level.
What stage are they conceptualized? During the formation of the city, or like, okay, the city is expanding, going beyond control, hence.
Generally is always lagging behind. You do not have that luxury to do it in the beginning that well. Although you like to do it, but generally they are always lagging behind. And a lot of these systems are very expensive, and like if you talk about the actual system, right, they are legacy systems which are there. So they have been developed, and they have been developed as per the need of that specific city. Because each city has its own unique characteristics, have their own unique traffic behavior, and the way people interact. So and also the number of modes which are there. So they are done in a step-by-step manner based on the funding which is there, but there is always a big lag. So you build your city, ideally you should be building these things from day one, but at that moment of time you just take whatever is off the shelf to implement it, and then you keep on modifying it as the need emerges.
When you look at firefighting, I'm not having the policy run with the government. The city builders think about it, and it's a different thing, saying that we are going to have a zero accident kind of road. Otherwise, we have seen this in many cities. I work in Bangalore, so it is really 10 kilometers. I think you will take actually more than 1 hour. More than 1 hour. So, and there is no traffic policeman. But we know that something is getting controlled, but we don't feel like it's not efficient. Maybe safety has become more important, but it's not efficient.
It's not efficient because of, I think it has to do with number of things. Is the demand and capacity ratio also plays very important role. If your demand is higher than the capacity, you cannot do much. So if you have, let's say, a lot of people wants to use, and your capacity is just limited. So if I have, let's say, 500 people who wants to come to this room, it's not possible. I don't have that much capacity. So if the demand has increased significantly high, system will go from bad to worse very, very quickly. Where these systems can really play a very important role is when you are approaching the critical point, after which the things go from bad to worse, which I will show in few slides from now, that why it is important to control. But these kind of control only work at that. You can delay the onset of congestion by shifting few things. You can make things like you can delay that, but at one stage you will have system congested, which is also an indicator of a good economy, because if people are moving, it means the economy is good. So congestion is not that bad. Congestion reflects that there is a good economic movement happening. I mean, if you have built the infrastructure and you have a lot of space there, you are totally underutilizing. So if I have a railway system and I am able to get my ticket no matter whatever time I am booking, it means that your system is underutilized, and it's not going to help the agencies there. Yeah, but again, these things evolve over time, and they are expensive. They are not easy to change, and depending on how the city has evolved, things actually emerge accordingly. Okay, I'm going to talk about number of traffic data sources here, which will be in the future lectures. Like I will talk about the inductive loops, Bluetooth, some of the incident records, and etc. Now I'm going to discuss one important concept, which is space-time diagram, which I am quite sure most of you should know that, but it is a very important diagram that helps you a lot to understand how the traffic behaves over space and time. So traffic is dynamic, we all know that it changes over both space and time. So when I say it's dynamic over space and time means at any given time the traffic congestion at different road sections will be different. So your spatial things have changed. Similarly, at any given location, the traffic condition over different time will be different. Early morning, evening, business hours, off-peak period will have a totally different traffic conditions. So it's all about time and space is very important to understand. What is time and space? Now, this is like a simple illustration that you have a vehicle moving on the road network. You have a x-axis as a time, y-axis as a space. If the vehicle is not stopping at all, that might be the trajectory of the vehicle having a constant speed. But if you have some other vehicle which is like this, let's say if I bring it a bit forward, some other vehicle which has to stop at the intersection, that might be the trajectory of that vehicle, and so on. We wish we have all these trajectories over the entire network. We never have that. We have few trajectories which I might show later on, but it tells you a lot about the behavior. For example, these two cars have stopped here. You can see the first car stopped there, second car stopped. So that's a space-time diagram, tells a lot about the mobility of one specific vehicle over the network. There are a number of things to note here. In this particular case, I'm just simulating, so I know its position every second. So each these points are perhaps maybe every second or maybe it's every second. It can be 1/10 of a second, it can be 30 seconds, it can be even a minute. So if I had every let's say 1 minute, I might have one data point here, one data point there. I might have one data point here, maybe one data point somewhere else. Then you have to make an estimate what's happening in between. So, but the space-time diagram tells a lot about what is happening over the network. In this particular case, we can, if I just show you this one, you know that there is something happening at this location, and that was the intersection. Vehicles are stopping and going. Obviously, the space-time diagram tells a lot about the dynamics of that traffic or that vehicle. In this particular case, in region 1, the slope of the line is constant, so that traffic is moving at a constant speed. Then slope is decreasing, so traffic is deaccelerating, has stopped, started acceleration, and then moving at a constant speed. So you can get the entire profile. You might have seen couple of like when people are doing the modeling for environmental assessment or environmental impacts, they need to know that trajectories. So they try to get the speed profile of the vehicles and then try to use the speed profile and apply some environmental models to estimate how much is the emission from those vehicles. And that is used a lot in traffic simulation to actually understand the emission based on certain strategy on the network. Now, that was just a basic one. Now, I want to show some real example from Queensland. This is from a bus trajectories. So there is a bus 550 route starting all the way from Browns Plain to Springwood, and these are two endpoints, and that's the actual bus route. It's around 28 kilometers, and it takes around an hour to go from A to B. And all these points that you see here, they are the bus stops. If I'm given a GPS data from the buses, how will you draw the space-time diagram here? The bus route is just you see the way it is. So what will you do for your space, and what will you do for the time? So GPS data, let's say I know the bus position let's say every 10 seconds. XY coordinates are known to me. How will you draw the space-time diagram there? Velocity, okay, and then? So every 10 seconds you calculate the velocity, but I'm talking about the space-time diagram. Let's say x-axis is the time, y-axis is the space. Sometimes you might have also seen y as time, x as space. It doesn't matter. It's just about you should know what the axes are. So how will you draw? Let's say I know the bus, each time the bus is at the bus stop, and I want to present it. What will you do?
So in space we can locate the bus stops.
Okay,
And
Right.
in time we can locate
the time. Yes, good. So that's what we do. So basically, you can think of this, stretch it around. You define a reference point, and from that reference point, you try to follow the bus route. So if you say from here to here, you don't do an aerial distance. You do the actual distance of the route. That becomes your y-axis. For example, here the y-axis is all the way from. So our reference point is 0, and the y-axis is actually the distance along the bus route. In fact, a long time ago when I gave the data to one of my student to plot the space-time diagram, and he had x-y coordinates, the mistake initially was done was they simply calculate the distance from point A to point B and keep on adding, but that distance is not the actual distance. If a bus is here and the bus is there, and you're calculating the aerial distance, that is not the distance. It's totally going to make your space-time diagram very bad. You have to know how far that reference point is from a starting point, or you have to move it along the bus route. And buses routes are never, in fact, road network is never straight. So you will, and so when you want to draw it, please keep that in mind. That was a mistake done, because when I gave that to one of the student, he did that analysis and come back, and I was not able to figure out why that space-time diagram is so zigzag manner. And that was because of the code that he wrote was not taking the distance along the bus route. So let's say now I have my y-axis defined, then x-axis is the time. That's not a big issue. The time is the time, right? And I can plot the trajectories as I am getting my data set, right? Now this is the solid line here. This is the actual trajectory. So as the data we got, it might be, let's say, 30 seconds or 10 seconds, and you find the distance from a reference point along the bus route. You plot those trajectories, and all these boxes that you see are the bus stop, just for our understanding where the bus stops were. The dotted line is something we thought to plot. We said, okay, we know the scheduled arrival time of the bus from a timetable. Can we just plot that also? So for example, if this bus is supposed to depart at 6:15, and maybe by, let's say, 7 it is supposed to be at this stop, then okay, 6:15, 7, or maybe whatever this, and you just make a dotted line joining those scheduled arrival time. Now what you can see from here is that two plots superimposed on each other, the actual trajectory that you are observing from GPS and a scheduled one. What can you do with this? What information you can get from this one? Delay, yes, yeah. So how much is the delay of the bus? How do we define the delay of the bus? What is the delay?
From 7:45 to 8:15, like there is a stop indicated in the
Yeah.
So like we can say that these are the like peak hours.
Okay, peak hours. Okay. What else can we know? So yes, I can see that this is a peak hour. This is a peak hour because the bus is having a different slope. Obviously, the slope of the line is going to tell me the average turning speed of the bus. So you can see that the slope is actually moving, is actually decreasing. So the speed is actually decreasing. If I want to find the average running speed from here to there, what I need to do is I need to know how much is the distance from here to there with the y-axis, and I need to know how much is the time. The slope if I draw a straight line from here to there, slope of the straight line is the average running speed of the bus, and you can see that the average running speed is changing. It's not the same. What else can you know? How do you measure the performance of the bus network? If you are at the bus stop, suppose you are standing here, this is a stop, this is your stop. What is the expectation? Should be on time. So on time performance is an important indicator. So if my expectation is the bus should be there by, let's say, 7 o'clock or 7:15, within 5 minutes if it's not there, for me it's delayed. I just use the word 5 minutes, just a threshold that you have in your mind, right? So on time performance is an important thing, which is for each of the stops. So you can see the on time performance of different routes at different time at different stops straight away. Can you see that? On time performance is not very good here, not very good here. It is pretty good for his part, but the on time performance has gone bad. How much was it on time for its initial departure? 1. How much is the running speed? And you can also figure out what sections the speed has actually gone down. Perhaps if you start looking at the average running speed, if these two lines are parallel until his point, but I can have a line going parallel like this, and I can have something that way. It means that after his part, my system is running fine, my traffic, my bus is running fine. It is the cumulative delay which has impacted. So on time performance for that part is also very bad because of something which has happened further upstream. Yeah. So for actually public transport, definitely trajectories are really one of the good ways to understand what's happening on the network. So
How do you measure this dotted line?
oh, this is from the scheduled arrival time. So if you know the timetable of the bus, which you should know that the bus is scheduled to arrive at this time, scheduled.
It's the ideal time.
Yeah, whatever was scheduled. So at each stop, for example here, my bus is supposed to depart every half an hour. 6:15, sorry, every 1 hour. 6:15, 7:15, sorry, 6:15, 7:15. There's 1 hour. This is half an hour. 7:50, 7:45, and so on. So every half an hour after 7:15, and his arrival time might also be accordingly over the entire route. So this is for the whole day. I mean, we try to plot that trajectory perfectly fine at 10:45, no issues, perfectly fine. But other times you can see, in fact, here 1:45, its departure time was also delayed. It didn't start at the same time. Now, what can be the reason behind this? Because these buses, as I told you earlier, they have a roster. So they were supposed to come at their starting point at a certain time. If they are delayed, they are delayed, and the subsequent, things. There's a domino effect. Delay at one is going to cause impact at delay at other. Now, if I have this data for multiple days, what can I do? I have for multiple days. If I start plotting over multiple days, I'm just plotting the trajectories, doing nothing else. You can see what's happening over the network. You can see the spread, and and if you have it for the whole year, you can do some pattern mining to understand there are certain patterns in your network. Perhaps your Tuesdays are the days when there is something happening, and like most of your working Tuesdays, things are behaving bad compared to other days. It can happen. So you will do the analysis on the data set and try to see what are the patterns, and then try to see, can I basically make my schedule better, or can I at least basically identify those symptoms or those actually choke points and do something for it. Now, generally, see, public transport is one of the most complex system that you ever have. It's very easy for us as a road user to say that a system is not working fine. It's very easy. As an academic, we will always write some papers to show that there is not optimal. But there is a number of constraints that the road agencies normally have. They have the budgetary constraint. They might know that yes, my schedule is my schedule trajectory is not perfect. I need to do some optimization, but they have to consider their budgetary requirements. They have to look at the whole network to make that decision. It's not something done overnight. So it's a complex system, and that's where your multimodal, or I would say multi-objective optimization really helps for you to see, look, I have certain objectives in mind, and based on these objectives, based on the constraint, this is the optimal I can do. So as I'm talking about the vehicle trajectories, I would just like to introduce one of the trajectory data set, which is widely used in academia, and I have seen number of PhDs and number of research done in that space. I thought to just introduce that, but I will use that to actually explain the concept of the vehicle trajectories further. Long time ago, there was a project in US. I say long time ago because it's like quite old now. They call it NG-SIM, which is the next generation of it should be SIM, not GIM. NG-SIM, sorry, next generation simulation data set, and they installed cameras at different locations on both motorways and arterials. How many of you are aware of NG-SIM data, or have you used NG-SIM data? One, perfect. Now, like for example, in I-80 motorway and similar, or the expressway or the freeway that you call in US, they have cameras to actually capture the trajectories, and then they have generated the trajectories for each and every vehicle. They also did it for arterials, and one of my students actually plotted, okay, I don't know why it's NS-GIM, it should be NG-SIM. X-axis is the time, y-axis is the space. Space is again, as I mentioned, space from a reference point as you move along that network. And all the trajectories actually they have shared, you just plot those trajectories. Now these trajectories are very important for calibration of your transport models. For example, if you want to run a simulation over the network, the carpooling model, there is a leader vehicle, there is a follower vehicle, and you have to calibrate that model. It has number of parameters. You can use these trajectories to do that calibration, and also you are important for a number of other fundamental research. And if you look at, there is a huge body of literature where people have used this data set. I know in India there is a lot of interest these days. People are using drone, and I think Akhilesh is going to talk about it tomorrow. That using drones just to get the trajectory. That is the starting point to develop your transport models or your vehicle movement model. This is another I would say space-time plot from the NG-SIM data from some other source. I don't remember from which paper I extracted that, but I used it long time ago. It is for different lanes: lane 1, lane 2, lane 3, lane 4, lane 5. What can you infer from here? If I show you this one, X is time, Y is space, 750 to 805, space is meters. The color represents speed in kilometers per hour all the way from 0 to 80. So if you are below 20, things are red. If you are above 60, things are blue. And obviously if you are between 20 to 40, you have some other color, and 40 onwards you head more towards the blue one. So what can you infer from here? Which one? Lane 1 is the most congested. Okay, good, very good. Because you see so many red dots there. Yeah.
There is a congestion activity happening at the end of all the.
Something happening here. Yeah. So somewhere around 8 o'clock. Yeah. There's something has happened in all the lanes. Yeah.
It might be peak time.
Yes. Okay.
Lanes are not utilized uniformly.
Good. That's why one is more congested than the other. So you don't have a good lane utilization. What can be the reason for not very good lane utilization? Think of the speed limit. No, speed limit should be same for all the lanes. Ideally. Yes. Think about your exit. So if you are driving or if you are in a traffic, if you have to exit in the next, you like to be on the left lane compared to the right lane, right? So your next exit, you always have a look ahead in your head. And if I have to exit after, let's say, 100 meters, you would like to go to your lane. Some of them might have a 100-meter look ahead, some of them might have a 500-meter look ahead. Each driver is different. There's a huge heterogeneity in the way we are driving. Safe drivers will try to be on the left lane from long time. Some of the more aggressive drivers might actually go until the end and then do the lane change, right? So we have all type of drivers on the network. So yes, the lane utilization is different because of your end destination. Other thing, especially because these are from expressways, or motorways, generally, at least in Australia, there is a rule that if the speed limit is over 80, you always are on the left lane first. We have a left hand driving in Australia, US is right hand driving. So you are always on your left lane. You only go on the other lane when the traffic is going down. So you try to be as left as possible in the beginning, and then you start, right? So obviously your lane utilization for a low traffic is very high in the left lane compared to the right lane. But as you have more and more traffic, lane gets utilized. But still the rightmost lane is generally considered as a fast lane. People try to drive there faster. All the people think there's a fast lane, but as per the rule, you are not supposed to exceed the speed limit. That lane is there to overtake. So if you have a driver at a speed of 80, maybe a heavy vehicle there and the speed limit is 100, you can overtake that guy by going on the right. Yes, the lane utilization is different. That has caused that's why you have a different ones. But again, there is one of the lanes where maybe the traffic wants to exit further down, and that's why there is some congestion happening. But other lanes are still having a free flow movement. Now, because of this speed variation among different lanes, system can be unsafe. Imagine a person, one of the lane has a speed of 40, other lane is still at 100. They want to do a lane change, accident can happen easily. So that speed variations causes a lot of impact, and then you have different control measures by which you try to minimize that speed difference among the lanes and among the sections, which I will discuss when I am going to talk about the variable speed limit concept. But this characteristic tells a lot about the behavior of your actually traffic on the network. This is another pair of trajectories, not the same as this one. This one was plotted by my student. This is I just captured from one of the papers, which I totally forgot from which paper it is. Here, this is an interesting one. I asked him to give me trajectories where differentiate them by different vehicle types. So dots are maybe the vehicle type A, maybe heavy vehicles. The solid lines are some other vehicles. But you can see that some of the trajectories all of a sudden they just vanish, or some of them just originate. What are these? Like what does these trajectories represent? The one which is not starting and just might have just vanished in between or have arrived. What do you think? What traffic behavior is showing in those trajectories? Entry from the lane. Yeah, from the lane. Perfect. So this is from one of the lanes. So this guy might have entered. Might have entered, and then might have left there, and then some other guy might have joined, right? Or maybe the data was in this case, because there are two separate ones, yeah. And then you have the entire trajectories. You can see traffic going up, then slowing down, almost stopping, and then going up, and then speeding up again. This also shows the phantom jam condition. This portion, you can see a band going in the backward direction, and you might have studied a shock wave. That's the shock wave actually. And this portion of the shock that you see here is what can be the reason why you have this. If you are driving like this and you go there and you have to stop for a while and then you accelerate, right? This is, we call them as a phantom jam, because if you are driving, you don't see any issue in this area. If you are on that part of the road, you don't see anything. It is something which has happened further downstream, and that shock is the one which is moving up that you observe. What can be the reasons for the shock? Lane change is one of them. Unnecessary lane change really causes the shock in the system. Breakdown. Yeah. So it's a breakdown of the vehicle, right? Somebody might have stopped, the lane might have been blocked, and if one of the lanes is blocked, then you have unnecessary, because if the lane is blocked, people have to do the lane change. That's the reason. Accident, that lane is blocked, the lane change is happening, that is causing. So lane change is actually one of them. And that's what they say when we have a fully autonomous system. System is getting autonomous. You are going to optimize your lane change behavior. Then you can minimize these kind of shocks. In fact, if you look at a simulation environment, if you're simulating that traffic and everybody is cooperating amongst each other, you can slow down, you can speed up, do the lane change. You never have shock in the system. And so lane change is actually one of the main culprits. Another space-time diagram that we widely use for before-after study. This is from simulation along a motorway section in actually Brisbane. So I was showing you the QTs here, and that was the bridge, which was actually a part of the motorway section, all the way from Springwood to the Brisbane CBD. So y-axis is that one, x-axis is the time. Here we are performing simulation, we know that trajectories, we got the speed contour plot. Again, what you see here is less than 40 is getting red, above 80 or 90 or 110 is getting green. So you can see a lot of patches of congestion over the entire network. There are certain sections where the system is never congested. They are actually behaving quite well. It's around how many, I don't remember, it may be around 30-40 kilometers of the motorway section. This part you can see a lot of congestion happening. So there is some traffic which is causing this. So it is again because of the lane change. It is actually because of the merging behavior. So traffic is entering the motorway section and they have to merge on the main line, and that is causing that congestion. But this is an important way of representing the current behavior. And let's say if I implement some kind of a control strategy, I might get something like this. This is without any control, this is with the control. So you again use your space-time plots to show the benefit of the investment done. So here you are saying that look, right now this is how your traffic behaves. If you're going to invest into a strategy A, that's how it's going to be from simulated environment. And that is going to make some case, why the importance of investment. Other thing which I want to highlight here is you cannot eliminate congestion. You're not eliminating the congestion, you are reducing the congestion. It's very hard to eliminate because after a certain time, the demand has exceeded the capacity. Things will go bad, but we can delay it. Any question on this so far? Yeah.
Introduce whatever examples, whatever interventions you're going for. How do you do that in the simulation?
Yeah, I'll show that to you when I'm going to talk about RAM metering. This is the project. In fact, it's among the first projects I did for the Department of Transport and Mains Road. For this project, what we did was we built a simulation model for the entire Pacific motorway in actually Emerson environment. We did the calibration of the model. So that was the first phase 1. Simulation model built, calibrated, done. In this course, I'm not talking about calibration of those models, but that was we did first. Then we built algorithm to perform RAM metering. That algorithm was performed in a simulated environment. So we wrote, like basically in simulation you can change things because it's simple computer program. Simulation, like for example, if I talk about Emerson or vSim or any such tool, they are the complete packages. They have, let's say, car following model, lane changing model, everything inside it. You don't have to code it from scratch. The packages are there, well documented, well studied, so that is there. With the help of an API, application program interface, it's a simple thing. You set and get functions. So you can set certain parameters in the simulation, you can get certain parameters from a simulation. So that's how you have a separate program you write outside the simulation environment or the package, where you can say, let's say, let me get the flow value from here, and based on the flow value I make some decision, set the RAM signaling parameter to something else. So get and set, and you do it at each and every simulation step. You can do that, right? Maybe I will in the future lecture I will try to show that flow chart, and that's what you do it, and you can train your algorithm on it. You can develop the algorithm on it, and when you have done it, you can say, at this time I have not performed any control. Now I have implemented my algorithm, I have performed the control, this is what I get. So that's how you show it in simulation environment. So simulation is a very valuable tool, and Now I will add some more slides on RAM metering part of it, where I will show that the work that we have done, and which I am really proud of, the team that they have done, was we built an algorithm in AIMSR environment. We did the factory default testing of the algorithm in the Steams environment. Means we have the whole API with us, and the Transmax was so, like, they set up a system where they can use this API as it is, plug in into the system, and can change the traffic parameters. So that's how your research can be implemented in practice, if you have done it in a very structured manner and in a very documented manner. But objective for this slide was to show you the importance of the space-time diagram, because when I talk about space-time diagram, or at least when I studied, I only studied the very first slide, which is the trajectory, that's all, but never thought the importance of it. And you can see the importance. You use it to present the case, you use it to, when you go out later on, and let's say somebody has funded you to perform that kind of work as a practitioner or as a researcher, they only want to see what's the end benefit. When you go and talk to the higher management, they want to say, show me the benefit. They're not interested in the code behind you, because they trust you are an expert in this area, you would have done something good, but tell me what's the benefit. This is how you can show the benefit. I can see some tired faces. You guys can stand and stretch yourself before we start the next one, please. I know it's normally, like at QUT, I have a 45 minutes and then I take a break for 1 or 2 minutes, then I start. I know, like, in fact, I'm from India only, so we can go long for 3 hours and we can sit there, but please stand and stretch yourself before I go to the next one. What is the next one? I don't even know what's the next one. Oh, next one, yeah, just, that's fine. What time is your lecture? Yeah, you got that. Yeah, that's fine. Thank you for asking questions. Yeah.
I have worked on this.
Oh, okay, good.
Master's from transport planning from
Okay.
So I worked a bit on this at a larger level. It was a 12 people project.
Yeah.
So I have worked a bit on it. But I actually wanted to know, like, what software other than that.
Okay.
Currently I'm doing a PhD in resilient infrastructure.
Okay.
So the first questions that I get is how do you find resilience
Yeah.
transportation network?
Yeah.
So my basic idea is how much time it takes to get back to the
Yeah.
basic
Yeah.
beforehand. So now the thing is, how do I convert it into a visualization
Yeah.
part of it?
Yeah.
Even if I bring up a framework or
Yeah.
anything, simulation is going to
Yeah.
happen in that.
Mhm.
That is why I'm trying
Yeah.
to understand.
This simulation is actually important tool, because you can control things, and whenever you are performing simulation or presenting the case, always tell the assumptions you have made. That's very important. So, like, for example, in this particular simulation, we have not considered heavy vehicles. We only considered the general cart traffic. No, we have simulated heavy vehicles, but we are not concerned much about that one. And that was okay, because this section of the motorway is coming towards the CBD. The heavy vehicle percentage is not huge. If it was slightly in the rural area, I should have considered heavy vehicles a lot. So we have not simulated heavy vehicles in this, but that is not the end objective. The end objective was to show how the RAM metering behaves. If you do a RAM metering, if you do not do a RAM metering. And so we tell those assumptions, and we say our results will not change. If you bring the heavy vehicles in, there will be slight differences, but at the end of the day, there is improvement. And the improvement, let's say the improvement is 15%. That's 15. It can be 20, it can be 10, but it's still 15% on average. So these things you have to always talk about. So when you do simulation, always highlight the assumptions made and say that these assumptions are not going to impact my end results. And end result, I'm not interested into the absolute value. I'm interested in the relative value. There is an improvement, there is an improvement, right? So that's how you should try to present it. Yeah. Oh, this one, I mean, for AIMSR, we use Python based programming, but again, different softwares may have different ways. I don't see there's a big difference between AIMSR and VSIM. Both of them might be using Python or whatever ways. Yeah. I mean they are actually pretty easy to do. They're not hard. It looks hard, but actual sense it is simple get and set. I said it's a get and set function. So you have a simulation model. Simulation is performing every 1 second you might be simulating, for instance. Let's say 1 second, 0.1 second, whatever you have set, simulation time step. So the way it works is at this time step, simulation knows everything what's happening. And before going to the next time step, it tries to read the external API. And in this API, you can get the values, whatever you want to get. So you use the get functions. Get me the flow, get me the occupancy, get me the speed, get me the percent, whatever you want to get. And then you use the algorithm to set. Say now set me these values accordingly. So when the simulation goes from this time step to that time step, it goes like this each time. So and it just performs that way. Same thing happens in your actual way when you control the traffic. You observe the things, you have an algorithm to make that decision, and you set your traffic parameters, in the next time step and so on.
So for feeding the traffic movement to the simulation, are we taking completely a peak hour thing or not?
This yes, basically you identify the time period when you have the issues, when you want to make some interventions. So generally they are the peak hours. In fact, peak hours are the hours when you have the high traffic, right? So you take a bit before, a bit after. It's not just the peak because you have to build the traffic. So you have a treatment period that you consider. So in this case, in this particular case which I have shown this one, it is the inbound traffic we are simulating. When I say inbound means CBD is here, a lot of traffic is coming inbound. Outbound means they're going out of the CBD. So evening is generally outbound, but that's the place where a lot of work is there, and people normally try to come inside or in the CBD. So this is the morning peak traffic. So the times are whatever times. I think this is from morning 6 a.m. to maybe 9 a.m. or something.
Sir, but few areas will be there. Every technique in Bangalore, you can see that few areas have a continuous movement of traffic. It is
Yeah.
so like an outer ring road.
Mm-hmm.
So at that time, how we have to simulate this.
No, you decide your treatment period, right? So if you're saying I might for my analysis, yes, it might be for the whole day, but for my analysis, I might be only focusing from 6 to 10 a.m. in the morning. I want to show my benefit. If you're able to show the benefit, the same thing when you apply in the other time period should also show the benefit. So you do not have to then do it for the whole day. Later on, you can do it for the whole day also, but generally you define the period you want to study first, and a period that you can manage. Right, certain time period that actually you can manage in terms of your analysis. Yes, I understand that you can have the whole day traffic, and which is there on all the peak. Bless you, on I would say some of the peak roads is always there, but you set up your time periods of interest. Yeah. Another example of space-time diagram which you might have seen when you are talking about traffic signals. This is basically you have different signals along the corridor. Space-time diagram is a very important tool when you are trying to perform coordination along the road network. You can see the traffic moving from A to B. In fact, this is from the department website. I think they have put that animation there to explain to the general public how the coordination really works. And you can see that's the kind of a band that we talk about when we try to optimize the signals, or when we try to coordinate the signals, not optimize the coordination. And there are different coordination algorithms. The bandwidth maximization algorithm basically tries to maximize this bandwidth. And the delay minimization algorithm tries to minimize the delay by keeping the certain band that you want. So this group of drivers will enjoy a green wave. Now I will talk about this when I will talk about signals, but here I am talking about the vehicle trajectories. But this trajectories can help you to have, okay, I have an in-class question actually, simple one. Oh, I also have an answer for it. Forget about it. So there is a through band that you see here. Let's say the saturation headway is 2 seconds. So during such saturated condition, the vehicle is moving every 2 seconds. So how many cars are observing the or enjoying the green wave. So question is, a single lane arterial corridor as shown in the figure. So a single lane, maximum throughput band is 40 seconds, saturation headway is 2 seconds. What is the expected number of vehicles per through band that will enjoy coordinated green? So this band is 40 seconds. What took you so long? I thought this was a very simple question. If it was the undergrad course, I would have shown this as an in-class example. In the exam, I would have changed from single lane to double lane. And students who didn't understand the concept well, they would have totally given the wrong answer. So if there are 2 lanes, the expected will be 40, right? Because it's double the lanes. Yeah, I thought I had another plot where actually if you want to do the dual coordination, it becomes very challenging, but I don't have it here right now. That's okay. So space-time diagram, definitely it's a graphical representation of space over time, as I mentioned, the very important one. But you can also use this, and I've only focused on trajectories so far. It can also be used for traffic parameters, and I'm going to discuss about traffic parameters from now on. So I'm going to talk about few of the traffic parameters. Continue or stop? You tell me.
Yeah.
Continue. Okay. What time you have to stop?
Maybe around 12:50 or so. Like you can give the basic parameters, then I can continue. Gradual complement.
Okay. So basic parameter we are talking about is basically headway spacing, volume flow, density, and speed, right? But I want to highlight more on the timing speed and space mean speed. Before jumping there, what is headway or time headway?
Distance between the two waves.
Okay.
Right.
Back. Okay, that's the space headway. What is time headway?
The time for one vehicle has passed and the
Second is coming. Yeah. So if I have, this is the point of observation. If this car hits here at time t1 and the second car comes again at time t2, the time gap is the headway. How much should be the safe headway on the road network if you are driving? Obviously different people have a different safe headway, but how much should be the safe headway? Sorry? 5 seconds. You are a very safe driver. Thank you.
Based on the reaction time.
No, safe headway. Reaction time is reaction time, but how much should be the safe headway? If you are driving on the road, what headway you should be maintaining in general? Depends on speed. Okay. Well, again, irrespective of the speed, the headway is the headway. So 5 seconds is very safe driver. Okay, he got 5 points. So, but I'm talking about the other, like it should be less than 5 basically. Then what? Okay, what? I know we don't keep headway in the mind when actually we are driving, but like if you go for a proper driving test or proper driving exam, when you go through the written one, there is like a theory behind it. Okay, there is certain time period you have to maintain. Generally in Australia, when you go for a driving, in fact, because I gave my driving test in Australia, I never drove in India. Well, I never had a car in India. So when you're driving there, it says that when you're on the road network, think of a pole and count 2001, 2002 in your mindset. So when you do that, you are maintaining a 2-second gap between the first and the one. So that the first car go, you count it, then you should be there. So you should try to maintain 2 seconds. But you will be surprised, 2 seconds safe headway. There are many drivers who might be driving in much less than that. What can be that one? It can be in 0.5 seconds. They can drive so, they can be tailgating. Definitely in Indian condition, the driving headway is much smaller. So this guy is always having a lot of people coming in, but that's actually a good one. So headway and spacing, they are two important parameters. As I said, for example, if you see, okay, before jumping on those parameters, there are two ways of observing traffic which you should have studied in your undergrad course. One is you are stopping along a roadside, observing the traffic as it is moving, right? That's one way. And in fact, some of the sensors like loop detectors, ultrasonic, microwave, they are focusing on one location and observing what is observing. So you might be observing the traffic as moving at that location. Other is you look at a stretch of the road and you observe what is happening in that stretch of the road. So there is a observation for a duration, observation for a specific length. So if I go back to my space-time diagram, I will never have all the trajectories with me. Yes, in certain areas you can instrument your cameras and observe, or you can take your drone and observe, but it is only for certain time period. It's not 24/7. So you never have all the trajectories. What you will have is, you might have an observer here and you only know this yellow portion of your space-time region. You have no idea what's happening upstream, you have no idea what's happening downstream. Similarly, if you have, let's say, a snapshot, you can know what's happening at different locations at a specific time, but you have no idea what's happening before, what's happening after. Now that was the old way of saying, if you have a video camera base and you are focusing a video camera on a specific stretch of the road, you can get all these things, right? But this concept is used to explain the concept of flow and density, how the two parameters are related to each other. As we have discussed, headway or spacing, they are pretty much the same thing, but in a different form. One of them is in seconds, other one is in meters. So you call this one as a time headway, and this one is a space headway, or spacing. Straightforward means it is a spacing. It's a time gap between two vehicles. How much is the spacing during the traffic jam condition on the network?
Sir, 7 meter.
7 meters. Okay. How much is the length of the car on the network generally, or just average length of the car? 6 meters. Okay, you guys have big car. Let's go. Okay. Yeah, I mean it can be, let's say, 4 meters, 4.5 meters, 6 meters. 7 meter is actually, I believe in Indian conditions it's much smaller because we always go bumper to bumper. So jam density is much higher. Normally it's around 5 meters is what we expect. So 7 is actually a bit higher side of it, and definitely not for Indian condition. If you look again the space-time diagram, the time gap between two vehicles, the horizontal distance is the headway, vertical distance is the spacing. And from here, the slope of the line is speed, so you can easily see that speed is equal to rise over run, or spacing over headway. You can find that relationship. I've already mentioned this, don't have to worry about this one. Now, it's an interesting thing, we have to figure out how do we define the headway on the Indian condition when the things are quite heterogeneous. And I will let Jyoti to talk about it, that how they are in the Indian condition, but this headway is an important concept that you should definitely have an understanding of. Next one is the macroscopic parameters. The first one is the volume or the flow. Both of them represent the same thing, but they have a different values or different way of expressing. So what is the difference between volume and a flow? It's only mentioned here, but can you explain that to me? Anyone? Yes.
Volume basically number of cars passing a particular point in the road
Yeah.
in a time.
In a time. Perfect.
It may change.
Yes. Yeah.
But the capacity of the flow.
No, flow. Capacity is different thing. Flow. Yeah.
Flow is typically it is fixed for a particular place. For example, in jam condition it's different.
No, that's not the
Sir.
right definition.
So flow is vehicle per hour per lane.
Yeah. Good. So there's a big difference. What you have mentioned is not the right way. No, I will discuss this now. So volume is the amount of traffic you are observing for a given time interval. Both of them are dynamic. They will change. I can have a different volume for the morning compared to the afternoon, or I can have some volume for first 15 minutes, then some other volume for the 15 minutes. Volume is the actual number of vehicles observed for a specific time interval. So you will have, let's say, hourly volume. In a lot of design problems, you want to figure out what is my expected hourly volume or what is my expected daily volume. It means that for the whole day, how many vehicle movement I am observing, expecting. So volume is for a time period specified, right? So it is a number, whereas the flow is the rate at which the traffic is flowing. It is a rate. So when you say the rate, it is number of vehicles per unit time interval. So as I mentioned here, volume is expressed in terms of 15 minutes volume or hourly volume or a daily volume, even the yearly volume, whatever you want to say. Flow is the rate expressed as vehicles per hour, expressed in terms of vehicles per hour or passenger car per unit per hour, per lane, whatever it is. So units are very important. Never ever miss the units in any calculation you are doing. I always say to my students, as an engineer, if you mess up with the unit, you have messed up with the whole thing, right? So units are very important. So let me give you an example here. Suppose you are standing along the roadside. From 7 to 7:15, you have observed 1000 vehicles. So this is 15 minutes time interval. So your 15 minutes volume was 1000, right? 7:15 to 7:30, you have 1200. So your 15 minutes volume for that time was 1200. They are changing. They are not the same. They will be dynamic. Similarly, from 7:30 to 7:45 and 7:45 to 8. But your hourly volume was 4300, right? So they are different values. Flow rate is the rate at which traffic is flowing. So for me, from 7 to 7:15, 1000 was equivalent to 4000 vehicles per hour, per lane, whatever you want to specify. Same. Now you can see the difference between the two. Hourly volume was 4300, but your flow rate is different for different time intervals. My flow rate is 4000 for the first 15 minutes, 4800 for the second 15 minutes, 4400 for the next 15 minutes, and 4000 for the last 15 minutes. Now with this example, can you think of the importance of a flow rate? What is the importance of a flow rate in traffic engineering? Suppose the capacity of the road, which is expressed in terms of the flow rate, is 4500. 4500 is the capacity of the road. What can you say from here?
Sir, from 7:15 to 7:30, there will be congestion.
There will be congestion. So that's the reason why the flow rate is so important. If I say the volume is 4300, the capacity is 45, perfectly fine. Okay, good. I can serve it. No, you cannot serve it because your flow rate is stochastic, it's changing, it's dynamic. That 15 minutes where my volume has exceeded the capacity, my flow rate has exceeded the capacity, I will have congestion on the road, right? And that is the point that I have to minimize. I have to reduce that, and that congestion can go from bad to worse. I'm going to show that example soon, but that is an important part of the understanding the difference between the two. Yeah. Generally, there are a number of traffic management measures, like you try to shift the demand from one time period to another time period. There are like for example, one measure is when I was at EPFL, we have two universities there, University of Lausanne and the École Polytechnique Fédérale de Lausanne, the EPFL, the two very close by, and there is a metro line connecting the two. A lot of traffic is there. And metro was, and generally students are the one who is using metro, is normally full. So what they did was, they said we are going to change the start time of the two universities, the classes. One of them is going to be at 8:15, other is going to have an 8. So by doing this, you are trying to manage the demand over the network. Now if both of the universities are starting at 8 o'clock and that line is serving both the universities, everybody wants to be there before 8, you have a huge volume, or huge demand for the time period. And that might be above the capacity of that metro line, or it is making things more congested. By shifting by 15 minutes, they are able to manage the capacity of the motorway line, of the metro line. So this is important, like you understand what time periods I have more demand and you try to spread that demand around. But this one was more to have for you to have understanding between volume and the flow rate, and we're going to use the flow rate a lot in traffic engineering. What's the relationship between flow rate and actually headway? Sorry? Inversely proportional to each other. So if I say that you want to maintain a 2-second headway on an expressway, how much is the flow rate then? How much? 1800 vehicles per hour. Yeah, that's good. So I don't have to spend time here. Flow rate and headway, they are inversely proportional to each other. So if I say 2-second headway means a simple mathematics proportion. Every 2 seconds there is one car following. So in 1 hour there will be 1800 vehicles per hour per lane. Similarly, what is the relationship between headway and density? So I have not talked about density yet, but density basically is the number of vehicles stretched over a specific road section expressed in vehicles per kilometer. So what's the relationship between headway spacing and density? Is inversely proportional, right? Same thing here. Oh, sorry. So spacing is inverse of density. So if your spacing is, let's say, 5 meter, the jam spacing is 5 meter, it means that your jam density is 200 vehicles per kilometer per lane. Yeah, I will stop here, and I think we have the next lecture starting. And when I start, I will come back to this class, right? We are on time or we are running late? It's fine? Okay. So now I will request Nibjali to come and talk about these parameters for the Indian condition. Yeah. You can do laptop?
Yes.
Yeah, you bring it here.
Yes, today's sessions are like bit tight, so maybe like even lunch time will be like very, we will not able to spare more than 1 hour.
Yeah.
So tomorrow onwards we might have little bit flexibility, but today like we'll request that you take quick lunch and come back by 1 hour.
Yeah.
What is it?
Yeah. HDMI US. HDMI
Maybe
is there,
Daniel, you share the e-rickshaws numbers in the WhatsApp group. So e-rickshaw facilities are available. You can call them. They can take you to the hostel. So that will be quicker way to move.